Right, can you guys hear me? Hello.
Hello, sir.
Right. Okay, how was the assignment? Some people sent some emails to me about they're unable to submit the assignment, right? Then how about others? Hello. How was the assignment?
It was doable, so I think mostly.
Mm-hmm.
Except the relay part for me, I couldn't do that.
Okay, right. So today's the final lecture, right? So I'm going to go through briefly on the previous lecture slides, right? So if you need something to clarify, then you can ask. Right, in the very first lecture, we discussed about what is physical computing. Right? So in you should have some like basic idea about what is physical computing and about what are the sensors and actuators, right? Sensors basically sensing the analog environment, right? Then actuators basically response for some particular event, right? So then discuss why we need physical computing and go through some overview. Right? Then, so in the paper, basically, so the first part will be come from some theoretical aspects, right? Some definitions and those stuff, and what are the differences between microcontrollers and microcontrol, those stuff, right? So you should have some kind of knowledge on these things as well, right? And after that, discuss about the Arduinos. Right? We discussed what is this Arduino platform, right? So, in why we using Arduino, what are the main key features Arduino has, right? And you should have some idea about the components, right? I'm not going to give you guys to draw the Arduino board, right? But you should have some kind of idea about what is the functionalities of each these components, right? So these things are basically from theoretical aspects, right? Discuss what is the crystal oscillator and why we need a crystal oscillator, and about these pin mappings, right? Then Then also you should have some idea about the pins and how we can utilize the pins, right? So same pins can act as it has different functionalities, right? We can use it as a normal digital pin or as a PWM pin, like that. Then someone asking about ARF pin, I think. We have ARF pin here. So basically, in ARF pins functionalities, like in the normal scenario, we have like a maximum value, maximum voltage that can in Arduino normally we have around, we can measure up to 0 to suppose 0 to 5, right? So if you need to increase uh, this range, right? So normally, suppose I can't remember the actual value, right? So it's around 5 volt or I can't remember, right? But so basically we are using this analog reference pins, right? So we can, if you need to measure some uh, voltage value like 20 voltage or something like that, right? So in that case, we can, so in normal scenario, we can't measure that much amount of voltage, right? So, but in the, if you're using this analog reference pin, we can refer some like outside analog wave or some voltage or whatever, right? So we can give kind of a input to this pin, right? Then we can, if we put like 10 voltage or something like that, right? So the maximum value, maximum voltage that can the Arduino can measure come to around 10 voltage, right? You can basically increase this upper limit, right? So that's the main function, right? So if you need to increase the voltage, right, then in that case you can use analog outside analog voltage, right? Then we can increase this range, right? The normal range we can increase the upper limit, right? But there are some maximum current these each pin can like read or write, right? So if so we should have some kind of idea about if we are putting around 1 ampere or something like that. So this will be totally right. So it has a maximum current that can take it out from each piece, right? So I can't give the exact value. So you have to keep those things in mind as well, right? Then we discuss crystal oscillator, then the pins. We have yeah, you know the pin modes, right? So each pin can act as either input or output, right? So in so you know like digital write, digital read, and analog read and analog write. So basically, so this analog write is some kind of special point, right? So you should have an idea about how we going to use the analog write. Whether so basically, if it is, we can read analog signal, right? But we can't write analog signal, right? That means we can't get analog output from these pins, right? In that case, we are using the method called PW, right? We discussed these things, right? You can go to the each video and have some idea. Then the ADC analog to digital conversion, right? So if we need to read the analog signal like this, right? So so we basically converting that into some kind of digital signal like this, right? If we increasing this, if we can increase this value, right? So the converted number of bits, right? We can get some kind of a smooth signal, right? So that's almost as the analog signal, the first we have, right? That is the analog to digital conversion, right? Also, you should have some idea about if you are referring some analog voltage like 3 voltage or something like that from analog pin, right? So how we can convert this into a, so this is, so if we referencing some value from analog pin, like we getting some kind of a number, it can be around 0 and 1023, right? Suppose this is 800, right? So you should have some idea about how we going to convert into a voltage, right? Suppose to whatever, right? Then how we going to write that voltage value out from this digital PWM pin or digital pin, right? So you should have some kind of idea about, so this in this value, it's around 0 and 1023, right? Then we can write values up to 255, right? So you should have some idea about how we go to do this calculation, right? So those are simple maths, right? You can divide that, multiply, then you can the answer, right? Then we discuss about the PWM, right? So it's basically pulse width modulation, right? So it's blink, suppose some it's basically have creating the pulses, right? So these pulses have very high frequency, then these kind of analog analog devices, so the analog devices, these things feel it's kind of a reduction on the voltage, right? So it has a set of duty cycle, right? So this is the duty cycle, right? So if it is 0, that means there are no that means 0 voltage, right? Then if it is 100, that means 5 voltage, right? Then if we have 25% or something like that, that means we keep on this for a 25%, right? And or for 75%, right? In that case, these signals have higher frequencies, and these signals sensed by the analog devices as a reduction of the voltage, right? So if it is 64, if you write 64, that means it's this much, right? So then you can multiply, you can get the set voltage, right? So then there are special pins that are dedicated for the PWM functionalities, right? In the Arduino Uno board, we have these set of PWM pins, right? So if we need to get some PWM signals, probably you should use this PWM pins, right? Otherwise, you can get the PWM functionality, right? Then we compare a set of Arduino boards in several aspects, like has different microcontrollers and has set of defined clock speed, right? And different time capacities, right? So you should pick the correct one that is very suitable for your scenario, right? So if you're just blinking an LED or something, right? So you don't need to use the Arduino Mega, right? You can either go for Arduino, but there are many other options, right? So you should, when you're selecting Arduino board, you should have some idea about these aspects, right? You should consider how much analog pins we're going to use and for digital pins, and how much memories we need, right? Those stuff, you have to have some idea about those aspects, right? Then we discussed the memory types. Then, so in the paper, you should have some idea about how to write 2 or 3 lines, right? Piece of code, right? So I'm not going to evaluate the whole code, right? So I just need to have some idea about how this function we can call that, something like that, right? We discussed these pin modes, right? First we discuss the setups and do the basic functions. Then the function pin mode, then digital write stuff, digital read and log read. So these are the basic stuff, right? So you should have a good knowledge on these things, right? And probably you have the idea about how to write the if condition, why structures, right? Then yeah. Then after that, then, we discuss about some variables and the data types we have in our mobile. Then how to get a reading from a sensor, right? So then these things we discuss, right? So I'm not going to give this kind of scenarios, right? The paper will be straightforward, right? So anyone can answer, right? So you have to have the theoretical aspects and the practical knowledge. So how to apply these things in a practical scenario, right? So like home automation or something like that, right? So what are the sensors you need? You don't need to especially remember the sensor, the model names or those stuff, but you should have some idea and what is about those each sensors, right? Then we discuss the interrupts, right? So interrupt basically means we have a normal code, right? We have a special set of code. Right? So it's like a condition. So if the condition is met, then in that case, this kind of a piece of code can execute, right? These are in the hardware level, right? So it's not like if else condition, right? So it's not, we don't need to like by using the interrupt, you can have some kind of a concurrent behavior, right? So then there are special pins for it if it's the external interrupt, right? So there are special pins, right? Then when we come to this communication part, right? In the interrupts, suppose you need to have some event like some kind of like some light intensity or some or the mixture of the air or sounds, whatever, right? So in that case, you can either you should use an external interrupt, right? So you should have idea about how to write the interrupt, right? So how you connect the interrupt to the Arduino board, like how you connect it to a special that there are 2 pins, right? So in Arduino we have only 2 and 3 pins, digital pins, as I think 2 and 3, right? So so you should have the how idea about how to write the interrupt, right? So that may be either you can use in the practical scenario, right? You can think about that and go for that using the interrupts, right? So also you have a kind of idea about the functionality of the interrupt, the theory behind the interrupts, right? So why we need such thing in our Arduino boards, right? So after that, we discuss about the someone asking about the sensors. I think I asked to cover that part in the practical. We see, right? So I'm not so if there are something not covered in the lecture slides, right? So probably it has a low percentage that will be appeared on the paper, right? So you don't need to worry, right? So some practical aspects I to cover on the practicals, right? We'll see. Then we discuss about the data transmissions, right? So serial and parallel transmission. Then serial transmission, synchronous and asynchronous, those stuff, right? Then comparison between synchronous and asynchronous, right? So these things are the kind of a theories, right? So you should like remember this stuff, right? Then the parallel transmissions, mode of transmissions, you know, right? Then set of protocols, right? So how we using these if it is UART, right? So how to like give me a minute. Right. Then if it is UART, then you have to have some idea about this thing, right? So so one TX connect to other microcontrollers RX, right? So TX connect with RX, this RX connect with TX, and after that you should have this common ground, right? So those things, then how the shift registers work, right? So how the data bits are shifting, those things. Then discuss about the someone asking what is the interrupt pin int one on the Arduino board? Is it digital pin 2? I think it's digital pin 3, as I remember with right in the interrupts. So right. So basically, we attach interrupt like this, right? So these are the keywords, right? Then if it's external interrupts, so either we should put 0 or 1, right? 0 for digital pin 2, 1 for digital pin 3, right? So if somewhere if you put 0, that means we are sensing the pin number, digital pin number 2, right? Then we should specify our function and our mode, right? So right. Then yeah. Then we discuss the parity bits, right? Then but even parity and not parity, or even parity is number of ones in the whole packet, so those are even, right? So result, that means number of ones are odd, right? Then we discuss some examples. Then we discuss what will happen if the send and receivers if it's at two different speeds, then we discuss what will happen, right? Then discuss these advantages and disadvantages. After that, we discuss about I2C SPI and one wire, right? Then how the I2C works, basically, right? So there is a kind of a procedure for before starting a communication, right? So it's like a handshake, right? So it has set of different steps, right? So you should have some idea about those things, right? Then advantages and disadvantages. Then discuss the SPI, right? In here also, right? So how the transmission works, right? You have the idea, right? Then this slide kind of have some advanced content, right? So the clocking nodes, you don't need to remember those things, right? Then discuss the advantages and disadvantages, right? Then about the one wire interface and the USB, right? So we discuss these things, right? So if you have any questions, so these are the previous lectures you can clarify. So if you need to clarify something, then you can ask now, right? If you have any questions, you can ask. Then about the structure of the paper, I think Dr. Hiran will give some MCQ questions as well, right? But I'm going to give two questions, right? So the first one will be based on some theories we discussed on the Arduino, the interrupts can be come from the interrupts, those things, right? Then some practical aspects, how to apply those theories, right? So if you know the theory behind the interrupt, so how are we going to apply that on the real world example, real world scenario, right? Like that. Then the PWMs, ADC, those stuff we discussed, right? Then about some theoretical aspects of these communications, right? Serial parallel, and we discuss UART, SPI, I2C, the main ones, right? Then so these things are the basic points I'm going to touch on the paper, right? So you can basically go through those lecture slides, right? So before moving to today's lecture, anyone need to have some clarification, then you can ask, right? Okay, then start today's lecture. So I'm going to spend around 30 minutes on this lecture, right? So I thought you have some questions to answer, right? So that's why I kept around 1 hour for the discussion, but so we'll see, right? So first, so we going to have some brief introduction on the wireless communication, right? So we have only around, so previously we have 15 minutes, but now we have 14 minutes, right? So because of that, I'm going to go briefly on these topics, right? So about the electromagnetic spectrum and some propagation modes we have, and some very basic stuff on the Bluetooth, right? So, so electromagnetic spectrum. So these waves are unguided, right? So basically, if we, it's like broadcasting, right? So suppose radio transmission, something like that, right? So you have a antenna or something, and you basically broadcasting, right? So these are unguided. That means these waves can travel in either ways, right? So you can't specify a direction. You can specify kind of a direction by there are several antenna types. Using those types, you can direct, but the waves, these things can travel in any directions, right? And the bandwidth, basically, so we are sending some, suppose we have kind of an antenna, right? We basically sending some signals, right? Suppose radio transmission center, some radio channel, right? So basically sending you a, suppose a song or something, right? Basically sending a song in kind of a waves, right? So there are some things, the keying and the modulation, and then encoding those things, right? We're not going to discuss those things in here, right? So those aspects will count on the embedded system fourth year, right? So I'm just give some brief idea, right? So we are some kind of encoding our data with this, there's a base signal. So using that base signal, we like, it's like suppose mixing stuff, something like that. Right? So you basically sending some your song as a wave, right? So so each wave there's a bandwidth, right? So this is the limitation, the how much information you can transmit, right? So it says a like it's basically depend on the bandwidth, right? Then so these signals basically uh, exposed to different noises, right? So it can be like coming from the obstacles, or another signal will like 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 overlapping or something like that. So the signals can be noisy, right? There can be internal and external noises, right? Then depending on the frequency, so these waves can penetrate, right? So if the, the frequency is lower, then the penetration will be higher, right? So that means like if you have a Bluetooth or something, right? So it has a higher frequency. In that case, it can't go through set of walls, right? But if you consider the radio wave something, right? So it can travel from a set of buildings, so it can penetrate through the objects, right? So basically, if the frequency is lower, that means the penetration will be better, right? So that means so it not obstruct by the obstacles, right? It can go through these uh, obstacles, right? It can penetrate through the buildings or whatever, right? Then as you can see, so this is our spectrum, right? So in here we have the visible light, right? So the frequency will increase to this side, right? So this radio signals basically have a very not very, but it has a like a lower frequency, right? Because of that, it can penetrate through the buildings, right? Then we have microwaves, infrared, like in the older phones we have IR, right? So in your remote you have IR, right? Like that. So if we increase in the frequency, if we go through this spectrum, you can see. So we can come up to visible light, right? We can communicate using the visible light as well, right? So we can encode it in some way, right? So there are some research going on, right? So how we, it's like if we now we using basically Wi-Fi or something, right? So but if you're using like turning on the switch and you turning on the bulb, right? That bulb will transfer your data like that, like in the mode of like in the visible light, right? there are some things on, yeah, there are some researches going on, right? Then we have a set of propagation modes, right? Now, up now we discuss. So we have a spectrum, right? So if the frequency is lower, we can penetrate through buildings, right? Then if the frequency getting higher and higher, so the penetration will be lower, right? Then so these waves are basically unguided, right? It can travel in either ways, right? Then so each these waves have set of propagation modes, right? So we're going to discuss three. So first one is the ground wave propagation, then skywave propagation, and the line of sight, right? So the ground wave basically means if we have a transmitting antenna and the receiving antenna, see these waves can like these waves can basically follow the contour of our Earth, right? So these things will flow like this, right? These waves, right? It has a lower frequency, right? So these things can easily go through the buildings. If we have set of buildings and those stuff, these waves can penetrate through these buildings, right? So the frequency will up to this kind of 2 megahertz, right? So so like AM radios and those stuff, basically using this propagation method, right? So you are lowering the frequency, right? So this, but the thing is we have low bandwidth as well, right? So it has low frequency. That means it has it can penetrate through set of obstacles. If there are set of buildings or those stuff, these signals can still penetrate through these buildings, right? But the bandwidth will be lower, right? So this is the ground wave propagation. So basically follow the contour, right? Then we have skywave propagation. That basically means, in our, so this is the Earth, right? So this is the atmosphere we have. In the atmosphere, we have a place, a thing called ionosphere, right? It's like, it's basically has the highest ions in that area, right? So it's like a kind of a shield or something like that, right? So if you need to, suppose there is a scenario like if you need, so this transmission and the receiving ends are in a with long distance, right? In that case, we can't either, we don't have the eyesight, right? We can't, so this, it's obstructed by this earth, it has a curvature of that. So it's obstructed by the earth curvature. In that case, we can go for the skywave propagation. That basically means we transmitting our signals, right? So these signals transmitting to the atmosphere. Then it's so this hit this ionosphere. It's like suppose the shield, right? In that case, hit on this ionosphere and it's coming back to the Earth, right? So again, it's reflecting by the Earth like that. We can do this skywave propagation, right? So in the skywave propagation, we can have higher frequency, right? So if we increase this frequency higher and higher, so the signals will go through this ionosphere as well, right? Like that, right? If it is within this 230 megahertz, so it has a lower energy, right? So in that case, that will reflect from the ionosphere, right? So this is the skywave propagation, right? Basically reflected by the atmosphere, right? Then it can go like several hops, right? It can travel this kind of hops and come to the receiving end, right? So it will reflect several times, right? Then like amateur and citizen-based radio, basically using this skywave propagation, right? So then we have the line of sight. That basically means we have a transmitter and the receiver, and there are no obstacles. Suppose there are no obstacles between these receiving and transmitting ends, right? So you have this line of sight, right? In that case, you can directly transmit the signal, right? So these things, like basically, if you need to communicate with the satellite or something, right, you can use this line of sight, right? So you have we have our ionosphere, right? But it has these signals have higher frequencies, right? In that case, so these signals will not reflected by the our ionosphere, right? That case, so the signals will, the waves will travel like this, right? It can go through this ionosphere as well, right? So it can either use for this kind of towards some transmitting and receiving it. So either we can use for like satellite communication, those stuff as well, right? So the thing is, this transmitting and receiving end should within the line of sight, right? Then so it has a limitation, right? If you are using 2 ground wave stations, right? So this Earth has a curvature, as I said before, something like this, right? So suppose you have one antenna on here and another antenna on here, right? So in that case, you don't have a line of sight, right? It has it's obstructed by this so this Earth curvature, right? So the the Earth is curved, right? In that case, you don't have a line of sight. So they telling that should have this kind of 30 miles distance, right? If you have higher distance, in that case, you should use the intermediate transmitters, right? So this will transmit to this thing, and this will transmit to this, is like that. You can transmit, right? Some televisions and this stuff using this line of sight propagation, right? Then if we consider a signal, right? So you can categorize a signal, suppose. So this is the transmitter, right? So if we have, so it has some distance the wave can travel, right? So so with it has, I think, it has this kind of function, right? So if so this is the transmitter, and if it is travel from transmitter, so each time so that this what we call the the energy, so energy will be lower and lower, right? So because of that, it has a higher limit, upper limit, that each signal can transmit some data, right? So we call that upper limit as this transmission range, right? In transmission range, if suppose you have a receiver, right? If you put receiver within this radius, right? So this we can do the transmission, right? So it has it's within the transmission range, right? In that case, we can do the communication, right? So it has the lower error, right? So then we have a range called detection range, right? The detection range, if you put our receiver on this kind of place, right? This receiver can see, it can detect there is a signal, there is some kind of a signal, but it can't get the data, right? We can't communicate with these 2 points, but the receiver can sense there is a signal, right? It can find, if we find the spectrum. So by if we consider there is a energy, we can see there is a energy, but we can't communicate, right? Because of the it kind of beyond our transmission range, right? So there is a long distance, right? So that energy getting lower and lower, right? But in this kind of detection range, we can see there is a signal, but we can't do the communication, right? So that is the detection range. Then we have the interference range. This range, so that is beyond the detection range as well. So if you put our receiver on this kind of place, right? So we can't detect there is a signal, right? Because this energy will getting lower and lower and lower, right? So that basically then in that case, this sending signal will appear as a kind of interference, right? As a noise, right? Like a background noise, right? So we have three ranges. If you consider communication, we have three ranges, right? First one is the transmission range. In the transmission range, we can detect there is a signal and we can do the communication, right? Then we have the detection range. In that case, we can detect there is a signal, but we can't communicate, right? Then we have the interference range. In that case, we can't detect there is a specific signal, right? So basically, these propagated waves will appear as a background noises, right? So these three are the main ranges we have in the propagation, right? Then any questions up to now? So since this is the last lecture, right? So there is a higher chance. So these things will appear on the paper, right? So the theoretical aspects, right? So how the transmission, how these waves propagating, right? So okay, then we can move to the Bluetooth, right? So some basically current very basic, right? So first these Bluetooth first appear to reduce the cable usage, right? So in the early days, suppose if we consider some computer or something, right? So we have the set of all the components are wired with the computer, right? If you consider computer, so all these stuff are wired, right? So there are a lot of cable communications, right? Because of that, so these cable communications have like a very small distance, right? Suppose 5 meters or something, 5 meter or 10 meter, right? It has a lower distance, suppose on your mouse, right? So that connected with your computer, right? So it has very small distance, right? Because of that, they come up with the thing called Bluetooth, right? To remove these cables, right? So it has a very short range. Within this short range, we can remove the cables and replace with the Bluetooth, right? You can have your new Bluetooth mouse, right? Like that. So originally, come to replace the cables in a short range, right? So Bluetooth, we have a very short range, if we using like Bluetooth headset or something, right? It has very short range, right? Then this stuff. Then this Bluetooth working on 2.4 gigahertz ISM band, ISM in the industrial, scientific, and medical band, right? So in the spectrum, they divide the set of ranges for set of special things, right? There are some frequency bands that are dedicated to like a military or something like that, right? So in Bluetooth, that's basically on the personal usage, right? ISM band, right? Then we didn't discuss these things, but so this Bluetooth, basically we can use it like it suppose it at for in early days we used to transfer some data, right? So you have your Bluetooth phone, you have Bluetooth on your phone, and we have the computer. Then we usually used to like transfer the stuff, right? Then after that we have our Bluetooth headset, right? So we can hear the music and we can transfer our voices through the Bluetooth, right? So this basically this Bluetooth can have set of range of applications, right? So in the like if you consider with the IR, right? So basically it has a very low range, right? And the very low data rate as well, right? So this Bluetooth come after the IR, basically increasing the those downside of the IR, right? So in Bluetooth we have higher data rates and higher range respect to the IR, right? Then in this we can so the data rate we can have up to this number, right? So this will differ from the Bluetooth versions, right? So higher the Bluetooth version, then we can have higher rates and higher range, right? So then we have set of classes in Bluetooth up to 100 milliwatt. We have, so if we put 100 milliwatt that class, that basically means we have higher transmitting power. So the range will be higher as well, right? Then class 2 basically that's lower transmitting power. So that means the lower the range. So in Bluetooth also it has like some things like set of modes, right? So each mode we can use for specific scenarios, right? Suppose there is a communication, right? In that case, so you can go for the higher higher transmitting power, right? But in the if there is no communication, then we can go for some sleepy modes, right? In sleepy mode, basically we have very low consumption on the power, right? So in the if you consider like some system, like some application, right? So the suppose you have some device like this, right? So basically for like to sense the outside temperatures and what is light intensities, and they are mixed something, right? So in that case, so you have a station to transmit this data, right? So in that case, so if there is a communication, in that case, you should switch to the high performance mode and do the transmission, right? Suppose this thing were once for like once a week or something like that, right? In that case, after the transmission done, so the Bluetooth or this stuff should go to the deep sleep or a sleepy modes, right? To save the power, right? So the in in our embedded these devices, so the main kind of aspect is the power, right? So you can't actually plug it to, you can always plug it to the our power this power source, no, right? If the our device is isolated and device is not connected with the power source, in that case, so device should uh, consume very low power to work for a long time, right? Because of that, we have set of sleeping modes, right? But in your level, we don't discuss the sleeping modes, right? So these things we'll discuss in the fourth year, right? Then basically the usage of the Bluetooth, right? These things you can read, right? Basically, we can use for like wireless headsets, those stuff, right? Then so the first step here of the Bluetooth to replace the cables, right? And the stage we have set of cables that we need to we need to remove those unwanted cables and replace with kind of wireless technology, right? First we have the IR, then after that they implement the Bluetooth. It has the higher data rate and higher range than the IR, right? So these things are the some usage of the Bluetooth, right? So with that, so the lecture is done, right? So you should have an idea about these propagation modes, right? Then about the propagation ranges, right? And some basic idea about the Bluetooth and why we need, so what is the purpose of, main purpose of the Bluetooth, right? So if you have that idea, in this lecture, then that will be fine, right? So any questions? So I kept around 1 hour for the discussion, right? So if you have any questions on the about the lecture or the about paper, about the assignments, then you can ask now, right? So the structure, I think you have a discussion with Dr. Hiran around 3 p.m. as I remember, right? So please attend to that as well, right? So he will tell you the, yeah, someone asking, so for the paper, do we get the practical questions from communication aspects? Maybe, right? Like you should have, suppose you should have some idea about what is the, so basic ones we discuss is the, we discuss UART, then SPI and the I2C, right? So there may be some questions to select the most suitable one for each communication and your justification, something like that, right? So you should have some idea about why I'm selecting this technology and what is the basic advantage we can get from using that communication protocol, something like that, right? Then what else? Okay. Yesterday during the seminar, I faced someone asking about the submission. I'll inform Tushar about your submission, right? You don't need to actually send it to me, right? You can CC me and send your submissions to Tushar, right? So the people who are submitting do the late submissions, right? So they will have to face a viva, right? So not just a very complicated one. You just have to justify your answer. That's it, right? Any other questions?
So in the assignment, we had something about noise filtration. We haven't done that like anywhere in the lectures, like not in the electrical lectures as well. So
yeah,
they won't be asked for.
Yeah, probably you will not get any question on that. Okay.
I guess.
What else? So the paper basically, so it will cover only the things I teach you in the class, right? So the other aspects are that are done on the practicals, that those things for your information, right? For the, if you like, so how are you going to do certain things in the practical world, right? So because of that, they have that set of things, but in here we covering a syllabus, right? We have set of learning outcomes. So to gain that, to like to fulfill that learning outcomes, we basically teaching the content, right? So if there is something that's not teaching the lecture, that won't be appear on the paper as well, right? Okay, any other questions?
So if you take something like an ultrasonic sensor, which you haven't done in the theory class, they have like a specific code, right? Like how to get the output, like the echo thing.
Yeah.
So would something like that be asked in the paper or not?
Not really. So I'm not going to depend on the sensors, right? So we will evaluate how to do the. So if we have that, so if it is 10 microseconds or whatever, so those information will be given on the paper, right? Using that information, you can do the calculation, right? So
This is not how to like the sketch or anything, right? So like trigger
no.
Right.
So if there are something to So there may be some content to support the question, right? So then you can feed. So not like the ultrasonic, there'll be an only sensor, right? So you don't have the idea about the sensor. In that case, we will provide you the information. So it will work in this range, and so these are the functions. This is the library we can use like that. I'm asking to draw and mark any electronic components part. So basically, I'm not going to ask to draw the components, right? There may be some questions to like name the components, so maybe, right? So I don't know. Still, the didn't think about the paper, right? So probably I'm not going to waste your time, right? So I'm not going to ask you to do the stuff, right? You can, there may be questions to name the components and what are the usage of the components. So these are very straightforward things, right? Also, there may be some practical aspects. So this is the scenario we need to fulfill this functionality. So how are we going to join these set of theories, you know, can be by PWM or DC or the interrupts, whatever, right? So are we going to use your knowledge to fulfill that requirement like that? There may be some tricky questions like that, right? In that case, you should have an idea about the interrupts and the PWM pins and PWM functionality and the ADCs, those stuff. What else we have? Any other questions? And also there will be, I don't know whether, so probably they will collect your opinion about the lectures, right? This course, right? You can give your honest opinion for that, then you can like review those comments, right? You don't need to like, you have your freedom of speech, right? You can tell whatever the things you feel, right? So be honest, right? So give a comment about the practicals or the lectures or the tutorial, those things, right? So we have, so the main, and I asked for that practical that you guys asked to do some kind of practical on the level. So I asked about that. I'm not sure that's going to happen, right? Because of the COVID situation. So if you saw the lab, so it has kind of a very small area, right? So in that case, so it can fill up to 20 people, right? So in that case, so we don't have the time, and if you're going to increase the number, then there will be a huge issue, right? So so basically we have that, we can utilize the time between the exam, but that's basically risking the whole exam, right? So in that case, if something happened on the lab environment, then so that will be an issue to your exam. Because of that, so we can't conduct the physical practical sessions, right? So I know it's like something that I know it's not comfortable, right? So, but the thing is, we don't have any other choice, right? So you can use the Tinkercad and do the stuff, right? And yeah. Yeah. Someone asking, will there be a chance to get in circuit design question? Not really, right? So those things will be appear on the analog side in the Dr. Hira's paper, right? In here, we basically in kind of a physical computing, right? So that circuit designing things will be on the analog side, right? So in my question, there won't be any circuit designing questions, right? Any other questions?
Yes, sir.
Yeah.
Sir, I have a question in this, like we had a question from that external interrupt section.
Mm-hmm.
So I have a question from that.
Go ahead.
In that one, so in that one, what we had was like we attached an interrupt for the high mode, and then when we press the button, it should Like if the LED is in low, then it should become up, and then if it is in high, it should become low, right?
Yeah,
So, but like when you run it and see, so like when you
yeah,
press
yeah,
the
yeah. There are so in if you do this stuff in the real world, there are the thing called debouncing, right? So if you press a button, there will be some noises and those stuff, right? So in the Tinkercad, there, so it has certain limitations, right? So if you have if you know the theory, then if you follow that theory, then that's enough, right? So in the practical scenario, those things will work in a different manner, right? So you should have some sort of things uh, to overcome those debouncing those stuff, right? Okay, right. So if it is high, that means if it that will trigger on the high, right? So in again in Arduino, if it is if the Arduino tells 5 voltage, that's not exactly the 5 voltage, right? If it is high, high doesn't mean 5 voltage, right? It has a range, right? That's kind of an error, right? Because of that, so some low voltage will not appear as not will detect as a low, right? So it's not absolutely 0 voltage, right? It can have. So in the Arduino it has a certain range, right? So if you're telling like low and high, right? It doesn't mean 0 and 5, right? In the actual aspects, right? If it is 0, that means it has certain range, right? I can't remember the actual range, right? Then again, if it is 5, it has a gain range, right? In some cases, the 0 voltage will be uh, detected as a low, but if it is in between some certain values, so the detection will be differ, right? So if we just have to follow the theory, right? If it is high, that means that will be triggered on high. If it is low, that means we trigger on low voltage. That means theoretically it can be like 0 voltage, right? If it is change keyword, that means changing the signal, right? It's trigger on the each time the signals change, right? Like that, falling edge, rising, there are certain things, no, right? So you just have to follow the theory. Then if you need to clarify, you can write the assumption you made as well, right? So we're not going to simulate this stuff, right? You just have to have the theory, and you can write to support your answer. You can write the assumptions, right? Like that.
excuse me sir.
Yeah.
සර් මේ ඔය දැන් ඉන්ටරප්ට් කරමු දැන් මේ හයි එකේදී මේ ඉන්ටරප්ට් අපි හයි එකේදී ඉන්ටරප්ට් එක මේ කෝල් වෙන හැදුවොත් සර් ඉන්ටරප්ට් එක දිග මේ ඉන්ටරප්ට් එක ගන්න මේ ඩිජිටල් පින් එක දිගටම හයි වෙලා තිබ්බොත් සර් මේ එතන කොහොමද වැඩ ගන්න? එතකොට ඒක එක පාට ඉන්වෝක් කරනවද? ඒ කියන්නේ ෆන්ක්ෂන් ඉන්ටරප්ට් එක රන් වෙන අතරේ තාමත් ඉන්ටරප්ට් එක කෝල් වෙනවා?
ඔව් කෝල් වෙනවා.
සාමාන්‍යයෙන්
ඒකට ඔව් කෝල් වෙනවා. ඒකට මම තමයි ක්වෙස්චන් එක ඩිස්කස් කරා. ඒකෙදී ඩිටැච් කරන්න ඕනේ ඉන්ටරප්ට් එක ඇතුලේදී ඩිටැච් කරන්න ඕනේ. නැත්නම් ෆන්ක්ෂන් එක ඇතුලේ අපෝ රිකර්සිව්ලි කෝල් වෙනවා.
හරි සර්. thank you sir.
මම පෙන්නන්නම් අපි ඩිස්කස් කරා ඒක මට මතක විදියට. ස්ලයිඩ්ස් වල නන්නේ මම හිතන්නේ මේ අපි ප්‍රැක්ටිකල් එකේදී මම හිතන්නේ ටිකකැඩ් එකේදී මේ ඉන්ටරප්ට් ෆන්ක්ෂන් එක ඇතුලේදී ඩිටැච් කරලා තමයි ස්ටාර්ට් කරන්නේ. ඊට පස්සේ මොකක් හරි වගේ ෆන්ක්ෂනැලිටි එක කරලා මොකක් හරි තියෙන මේ කෝඩ් එක රන් කරලා ආපහු ඇටච් කරලා. හරි. ඉස්සෙල්ලා පටන් ෆන්ක්ෂන් එක පටන් ගන්නදී ඩිටැච් කරලා තමයි පටන් නැත්තම් මේ අර ආපහු ට්‍රිගර් කරගන්න ගන්නවා. ඒක රිකර්සිව්ලි කෝල් වෙවි යනවා.
දැන් සර් අපිට කියන්න බෑනේ සර් මේ කොයි වෙලාවෙ يعني ෆන්ක්ෂන් එක ඇතුළේ කොයි වෙලාවෙද රිකර්සිව්ලි කෝල් වෙන්නේ කියලා. අපි ඩිටැච් කරේ නැත්තම්.
ඔව් ඒක මොන ප්‍රශ්නයක් තියෙනවා.
හරි සර්. thank you sir.
තාම මොනවද ප්‍රශ්නේ? Tinkercad එක use කරන්න ඒකේ predefine එක හදපු circuits එකක් තියෙනවා. ඔයාලට ඒවා try out කරන්න පුළුවන්. හරිද? සමහර ඒවා කියන්නේ 100% වැඩ කරන ඒවාත් නැහැ කියන්නේ.
කරන
හරි වෙන මොනවද ප්‍රශ්න තියෙන්නේ? හරි පේනවනේ මෙන්න මේ වගේ කියන්නේ ආගේ මොකක් හරි ලියන ෆන්ක්ෂන් එක LED මොකක් හරි වෙන ෆන්ක්ෂන් යන එක පටන් ගන්නකොටම ඩිටැච් කරලා ඉන්නවා හරි මේක මේ ඩිස්කස් කරේ මෙතන ස්ලයිඩ්ස් වල නෑ මම හිතන්නේ ඩිටැච් කරලා තමයි පටන් ගන්න ආපහු ෆන්ක්ෂන් එක ඉරෙද්දි ඇටච් කරනවා එහෙම කරේ නැත්තම් වෙන්නේ මෙතන අපි ඩිටැච් කරේ නැත්තම් මේ ෆන්ක්ෂන් එක ට්‍රිගර් කරගෙන මේ ෆන්ක්ෂන් එක එක්සිකියුට් කරගෙන යද්දිම ආපහු මොකක් හරි ඉලිතින ඉවෙන්ට් එක හිතන්නකෝ මේ රයිසින් කියලා දීලා තියෙනවා මේක ට්‍රිගර් වුණොත් එහෙම ආපහු මේ කෝල් වෙන ගමන්ම ආපහු මේ කෝල් වෙනවා එතකොට මේ අපි normally මේ මේක interrupts basically using like in the very critical situations right so the main thing is to complete the whole piece of function right piece of code so we need to completely execute the whole code, right? Whole function. So in this case, that is LED function, right? So if we didn't use this detaching one, so that will suppose you are this kind of executing this line. In that case, so if the interrupt triggers again, right? In that case, so again it start to execute from the top of the sections, right? So you start again your calling your function again, right? In that case, so the previous execution is not completed, right? In that case, there may be some abnormal, it basically don't give us the expected result, right? Because of that, so the first we should detach, right? In that case, so that now the interrupt is detached, right? Then executing each line. While executing, if this interrupt is triggered, right? So it can't trigger because we detached, right? We turn off this interrupt, right? Because of that, this phone call this interrupt function again, right? Then we can peacefully execute our code. Then after that, we can again attach the interrupt, right? Turn on the interrupt, right? So after that, in this case, again the interrupt is the condition is made. Again, it can call the function, right? So the main thing is to completely execute the whole piece of function, piece of code, right? For that, we can use the detaching. Okay. Any other questions?
So for something like toggling this LED, we don't have to use an interrupt, right?
So you mean like on off the LED, something like that?
Using the push down button.
No, we don't need to have the interrupts, right? So we basically using the interrupt if we need to get that kind of a concurrent behavior, right? So in here, I think I have two behaviors, right? So one is counting the numbers, right? So basically counting the numbers, and while counting the numbers, so I need to react to the outside this kind of event as well, right? While counting the numbers, if I press this button, I should react on that, right? So if you use the if else thing, right? So it will not work, right? So it will work, but that concurrent behavior we can see by using the effects, right? So those things are triggering on a sequential manner, right? So these things are also sequential, but the thing is these are hard attached in the hardware level, right? So it has the higher clock, higher frequency, right? It can switch between these two, right? So while counting, it can react on this as well, right? So that's why we use the interrupts to get some that parallel, like working on the parallel, right? The concurrent behavior, right? So we can do some work, and while doing that work, we can react on another event as well, right? That's the main thing. Okay.
It's
Okay, any other questions?
Hello, excuse me, sir.
Yeah.
So මේ අර මේ බටන් එක ප්‍රෙස් කරගෙන ඉන්නකොට මේ අරක පත්තු වෙනකොටම අර මේ නම්බර්ස් ටික ගන්න ඕනේ. සර් මේ එතන මේ කොන්කරන්ට් එක කොහොමද වෙන්නේ? actually අපි බැලුවම අර සීරියල් එකක් විදිහටනේ එන්නේ පොඩ්ඩක් අර
fundamentally sequential තමයි. හරිද? that obvious no. අපි මොකක් හරි processor එකක් මොකක් හරි use කරනවා නේ. ඒක basically sequential, right? අපි ලැප් එක use කරනවා කියලා හිතන්න. හරිද? අපි ලැප් එක use කරද්දී ඔයාලා මොකක් හරි සින්දුවක් අහනකම ඔයාලට මොකක් හරි lecture slide එකකට මොකක් හරි බලන්න පුළුවන්. හරිද? එතන අපිට concurrent behavior අපිට පේන්න තියෙනවා. But if you go down how this piece of code execute on the processor, that's basically a sequence, right? We are basically increasing the clock, right? Clock එක අපි ගොඩාක් increase කරලා තියෙන. එතකොට අපිට ඔය switch වෙන එක තේරෙන්නේ. අපි කියන්නේ කොහොමද time sharing එක නම් තියෙන processor එකක් ගත්තාම මේ දැන් අපි මේ context එක හිතුවොත් අපි ගාව මොකක් හරි code එකක් තියෙන. ඒ code එක කරන ගමන් තව code එකක් ටක් ගාලා execute කරලා අරයට අතෙන්ට එන්න පුළුවන්. මොකද clock speed එක high, ඒක clock speed එක වැඩි. හරි. එතකොට අපිට අර switch වෙන එක අපිට delay එකක් තේරෙන්නේ නැහැ. ඒක කියන්නේ concurrent
frequency එක වැඩි කරන වගේ එකක්ද කරන්නේ? අර බල්බ් එකේ නිවලපත් වෙන frequency වැඩි කරාම අපිට පේන්නේ නැහැ ඒ වගේ සිග්නල් නේද?
ඔව් ඒ වගේ එකක් තමයි දැන් අපි Arduino එක use කරලා අපි ලියනවා නම් අපිට ලියන්න වෙන්නේ sequential විදියට. හරිද? ඉස්සෙල්ලා මේක කරන්න. ඔන්න දැන් අපි හිතන්නකෝ අපි මෙහෙම කරමු. අපේ මම හිතන අපි මේ කතා කරා කලින් දවසක දැන් අපි හිතන්නකෝ මේ තියෙන මගේ for loop එක මම මෙතන basically count කරගෙන යනවා. හරිද? එතකොට දැන් අපිට places basically හතරක් තියෙනවා. මේක අපි ගාව මෙතන lines තුනක් තියෙනවා. හරිද? අපිට දැන් අපි දන්නේ නැහැනේ කොයි වෙලාවෙද අපි බටන් එක press කරන්නේ කියලා. හරිද? එතකොට මෙන්න මේ place එකේදී බටන් එක press කරන්න පුළුවන්. හරිද? ඕන මෙතෙන්දි බටන් එක press කරන්න පුළුවන්. මෙතෙන්දි බටන් එක press කරන්න පුළුවන්. අපිට if else එකක් දාලා ඔබ කරන්න පුළුවන්. හරිද? කරාට එතන අපිට අර expect කරන අර concurrent ගතිය බලන්න බෑ. මම හිතන්නේ මේ අපි කලින් lecture එකේ මේක detail කතා කරා. හරිද? එතකොට අපි කරන්නේ දැන් අපි interrupt එක use කරාම හරි හිතන්නකෝ අපි දැන් මෙන්න මෙතනත් නෙ මෙතන ඉන්න පටන් ගන්න setup එකේ setup එක ඔන්න මෙතනට ආම interrupt එක attach කරා ඊට පස්සේ setup එක call වෙලා ඉවරයි ඊට පස්සේ අපි නා loop එකේ දැන් අපි loop වෙවි මේක execute කර යනවා හරිද execute කර යනකොට එළි ඉන්නවා මේ attach කරපු interrupt එක හරි ISR එක තියෙනවා මේක අපි ගාව මම හරි function එකක් තියෙනවා හරිද දැන් එතකොට අපි if else එකක් දැම්මොත් අපි හැමතිස්සෙම check කරන්න ඕනේ මේ බටන් එක press කරලා නා මෙන්න මේක call කරා හරිද ඕක හැමතිස්සෙම check කරන එක කරන්න ගියාම එතන කරදරයක් වෙනවානේ හරිද ඔයාලට කොහොමද delay එකකුත් තව වදිනවා හරිද එතකොට ඒක නිසා අපි කරේ මේක අපි දැම්මා මේ interrupt එක hardware level එකකින් තමයි තියෙන්නේ හරිද එතකොට අපි attach interrupt මෙතන 1 නේ තියෙන්නේ 1 කියන්නේ pin number 3 හරිද මෙතන pin number 3 ඉන්නවා එතකොට මේ pin number 3 එක දිහා hardware level එකකින් නම් අර monitor කරන් ඉන්නේ හරි pin number එකට මොකක් හරි pricing edge එකක් ආවොත් එහෙම එයා ටක් ගාලා hardware level එකේ ඉන්න මේක execute කරලා දාන්න. මේක කරලා ආපහු මෙයා නැවතිච්ච තැනට එනවා. හරිද? දැන් මේක වෙන්නේ හිතන්නකෝ මේ 10 10 to the power 6 හරි මොකක් හරි value එකකින් කියලා. එතකොට අපිට මේක අල්ල ගන්න බෑ. අපිට තේරෙන්නේ මේක මේ parallel work කරනවා. මෙතන අපි බටන් එක press කරා මේකට react කරනවා. මෙතන count එකේ වෙනසක් වෙන්නේ නැහැ. count එකත් තප්පරෙන් තප්පරේ count එක යනවා. හරිද? අපිට ඒක පේන දෙයක් විතරයි. ඇත්තටම බැලුවම හැමදේම sequential තමයි දුවන්නේ. හරි. sequential දුවන්නේ නැතිව තියෙනවා. ඒකට මේ කියන්නේ මේ FPGA කියලා 4th year එකේදී වගේ හම්බෙයි. හරිද? එතෙන්දී අපි මෙතන තියෙන්නේ අපි මොකක් හරි එකක් instruction එකක් මොකක් හරි execute කරන එක FPGA එකේදී වෙන මොකක් හරි අපිට ඕන behavior එක gate level එකේම හදා ගන්නවා. gates තියෙනවා. and not gates තියෙනවා. ඒ gates ටික use කරලා අපි circuit එකක් හදා ගන්නවා. ඒ circuit එක නිකන් just කියනවා දැනගන්න. හරිද? මොකක් හරි හිතන්නකෝ අපිට මේ lights දෙකක් lights මොකක් හරි blink කරන මොකක් හරි behavior එකක් ඕන කියලා. අපි ඒකට කරන්නේ මොකක් හරි ඒක තියෙනවා languages තියෙනවා Verilog හරි VHDL හම් කියලා languages තියෙනවා hardware definition languages ඔය use කරලා අපි හදනවා circuit එක. එතන නැහැ instruction to execute. එතන තියෙන්නේ just the circuit, right? circuit එක ගත්තාම අපි දන්නවා circuit එකට power එක දුන්නාම මොකක් හරි gates ටිකක් තියෙනවා. හරිද? එතකොට මේවා already connected. මේ පැත්තේ inputs ටිකට මේ පැත්තේ මෙයා outputs ටික fire කරලා දානවා. එතන වෙන FPGA වල තියෙනවා මේ ඇත්තටම parallel behavior එක. හරිද? මේ ඒ ටික මේ 4th එකේදී කතා කරයි. එතෙන්දී විතරයි මම දැකලා තියෙනවා parallel work කරන එක. අනිත් හැමතැනම අපි processor එක ගත්තොත් ඉතින් අන්තිමට sequential තමයි දුවන්නේ. එක මොකක් හරි එක instruction එක කරලා තමයි අනිත් එකට එන්නේ. අපිට එක algorithms තියෙනවා මේ time share කරගෙන මේවා මේ instruction එක පොඩ කරගෙන යන්න clock එක වැඩි කරලා එතකොට අපිට තේරෙනවා අර parallel වැඩ කරනවා වගේ කියලා. But from the bottom level that's basically a sequential, right? So only the as I know only the FPGAs have that parallel behaviors. Any other questions?
Thank you, sir.
Any other questions? Not the questions here either. හරි ඉතින් අපි lecture එක නවත්තමු. හරි එහෙනම් හොඳට exam කරන්න good luck.